In this question, you asked to plot a graph of pressure against temperature using the data given in the table. The graph should allow you to accurately determine the gradient. Okay, so here's an example of a graph that students tend to draw. The reason why they've drawn this is because they've got the origin on the bottom left, 0, 0. But the problem with this graph is it's not going to allow you to determine the gradient very accurately. Because when I draw the gradient over here, and then I try to, for example, take change in y, I'm taking a very small reading over here. So the uncertainty caused by that reading of y2 and y1 is going to have a large impact. So it'll have a very large percentage uncertainty in my gradient. Okay, the same set of data here, except I've used a different scale now. As you can see, I'm not going through the origin anymore. So this allows me to use more of the graph paper to actually figure out the gradient. So now the next step is to draw a line of best fit. So here's an example, but the problem with this one is that a lot of the points are below that line here. So it needs to be roughly equal amount of points above and below. Here's another example of one, but this time I think the deviation of a lot of these points from the line of best fit is too much. So a lot of them are a bit far from the line of best fit. So try again, and this one seems to be better, it's a lot closer. Okay, so then next I can determine the gradient using change in y. So as you can see, if I do the change in y now, I'm taking a much bigger reading here. So even the same uncertainty will give me a smaller percentage uncertainty. So I'm more likely to be accurate with my gradient. Okay, in this example, you're asked to choose a suitable scale to plot s on the x-axis and t squared on the y-axis. Let's start with the x-axis. So we've got 7 big boxes, the 10 by 10 small squares in there, and the range over which we're plotting the s is 0.3 to 0.9. So the difference there is 0.6, and we've got 7 big boxes. So I can just do 6 big boxes. I don't have to use the whole thing. As long as I use approximately 3/4 of the graph paper, that'll be fine. Okay, so here's a set of example of values I can go from 0.3 all the way to 0.9 like this. Okay, now for the y-axis, I've got 8 big boxes here, and the range for the t squared is going from 0.059 to 0.185. So I'm not actually going to plot 0.59 because that's not going to be a nice round value. So I might take it from 0.055 or even 0.050. Okay, so the range, if I use those numbers, is around 0.13 is what I'm plotting on the y-axis. So if I try to split that over 8 big boxes, it doesn't quite make sense. So what I think about it is instead think of it as like 16 smaller 5 by 5 boxes, in which case I can fit that 0.13 in there. So I'll try, for example, use 13 5 by 5 boxes for 0.13. So if I put that onto the scale, it looks a bit like this, and then I can add on the line of best fit, and as you can see, I'm using at least 3/4 of the page, which will allow me to determine the gradient quite accurately.